Today we're going to take a look at section 1.7, which is Intro to Exponents and Order of Operations. In particular, I had an interesting order of operations text message from a previous student, and we'll finish up with the lesson with that particular text message today because it was very interesting that it happened so close in proximity to when I've taught it in both sections of this class. So starting with exponents. Exponents is really the process of repeated multiplication. It can be represented through the shorthand use of exponents. So when we say a raised to the power of n, it means a times itself in times. And it works for whole numbers. It would work for negative numbers. It will work for fractions. You can do it with variables, and it's all the same process. And we'll talk more about section 1.8 that we do next time. We'll actually extend our conversation of exponents quite a bit. So we're just introducing it today. So if we're taking a look at 3 raised to the power of 4, it doesn't mean 3 times 4. It means 3 times itself 4 times. So here's where you see that there's 4 of the 3's. You can progressively multiply them from left to right. You can pair them up and multiply them if you'd like, right? 3 times 3 and 3 times 3. That gives you 9 times 9. 9 times 9 is 81. No matter what order you do it in, you'll get the same value. Okay? So I mentioned negatives and I mentioned fractions, and that's actually what's happening on the second example, both of those things. So squared means to multiply it by itself twice. So I have negative 2/3 times negative 2/3. We've had a couple sections of material over fractions. So you know that you can multiply across the top and multiply across the bottom. So across the top, negative 2 times negative 2 is 4. And 3 times 3 is 9. So notice, I don't end up with a negative number because I multiplied a negative times a negative here. So you're going to have just some real straightforward questions like this about exponents. Our next section is going to have a lot more with exponents and a lot more detailed kind of problems, but this one's just an introduction. All right, so the bigger focus of our attention in this lesson is actually on order of operations. We mentioned the exponents because they're part of the order of operations. That's actually why I've mentioned them right now. So order of operations, you've probably seen PEMDAS before, or something that's sort of like it. There's a different one that's used sometimes too. I can't remember what it is. I saw it at a conference once as an alternative. But PEMDAS, I think, is still probably the most prevalent. So do you guys remember what the P stands for? Parentheses. And when I see the word parentheses, what it means is to simplify inside of the parentheses. So if there's anything that can be combined or simplified within the parentheses, it's not about removing parentheses. It's about simplifying within them. E, what does E stand for? Exponents, and again, that's why I've mentioned them briefly in this section, was because we're going to encounter them briefly inside of order operations. You may not be aware that the M and the D in PEMDAS don't have an order. They feel like they do because you say PEMDAS, right? M comes before D in the word. But they actually don't. It's MD or DM, all right? So we could say PEMDAS just as easily. I mean, it sounds funnier. But we could say that, and it would actually be technically correct, too. So what does that mean? Well, it means multiplication and division is a single step. You do them from left to right. So M and D is to multiply, divide, but then you do this from left to right. So there might be cases where you actually do a division before you do a multiplication, okay? And the addition subtraction's the same thing. The AS could simply say SA. So we could actually do PEMDAS. That's terrible, right? Like if I just reordered things, that's terrible. There's a reason they did it. It's because it's easy to say. It's not because we really have to do addition before we do subtraction. So again, this is addition, subtraction, or I'm going to write just add, subtract. And the reminder is that we move from left to right. So again, you may subtract before you add. Okay, so order of operations is one of those man-made conventions. I mean, this is not an innately, everybody had to do it in this way. This is a man-made convention. It's done so that when I do the problem and when Abby does the problem, that we get the same answer, right? We need some kind of structure so that we're all on the same page when we're working mathematical problems. And so this is the structure that has been imposed upon us, not because it's any better than anything else, but because we just need something that's all unique, that's all common, right? So we're going to do some examples of some order of operations problems. So as you take a look at number 1, tell me what operations you see here. There's an exponent, right? And there's also division, right? So which of those two things should happen first, the exponent or the division? The exponent, right? Because the exponent comes before the division in our PEMDAS or PEMDAS order of operations. So 6 squared, what is that? 36. So we'll do them order of operations, exponents first, and then we'll do the division. So what is 36 divided by -2? -18, exactly. Okay. So number 2, what operations do you see? Yeah, we see actually all 4 of the basic operations, don't we? Multiplication, subtraction, division, and addition. So we don't have, sort of in this order of operations, anything that's above the multiplication, division. We've got multiplication, division, and addition and subtraction. So we'll do the multiplication and division first, moving from left to right, which means first we will multiply 6 times 2. 12. And then there's a subtraction sign, a negative, because then we have -16 divided by 8. -2, right? And then we have our +2 at the end. Okay? So moving from left to right, doing the multiplication step and the division step at the same time. And then we're going to move from left to right, doing the addition and subtraction. So we're going to first do 12 minus 2. So that's 10. I'll write it down just so that you can see that we did it. And then we're going to do the 10 plus 2, which would give me back to 12. So we're moving from left to right. Okay, any questions on either of those? So the next one's a bit messier. Okay, so what do you see happening in 3? There's parentheses, there definitely are. What else? Addition and multiplication, and there's subtraction as well, right? Okay, so we actually see parentheses and we also see brackets. Okay, so for the purposes of discussion, brackets are just another form of parentheses. They're not anything different. We kind of have this natural embedding, but it's really more about keeping track of where all of our things start and stop than it really is about them being different, okay? They're just grouping symbols. So we're going to start with the grouping symbols that are the innermost grouping symbols, and that's the 7 minus 8 part. Okay, so parentheses, PEMDAS, P, we actually have that on this problem. We're going to simplify within the 7 minus 8 first. So what is 7 minus 8? -1. Now, you can either leave it written with the parentheses around it, or you could eliminate the parentheses around it. It really wouldn't make a lot of difference at this point. Parentheses is just a way of separating or keeping them set apart. If you're looking at it like this, there's nothing to simplify within it. So still, we have grouping symbols, the brackets. So we still need to clean up within the brackets before we move outside of the brackets. And within the brackets, you see that we have an addition step and a multiplication step. Which one will we do first? The multiplication step. So this 2 at the beginning will stay here. And now I have -1 times 6, which is -6. So you'll notice I eliminated the positive that was in there. It's positive, negative. That's awkward, right? We don't put plus, minus. That's just not necessary. I eliminated it in favor of just writing the single negative, which is the same meaning. Okay, we still have parentheses, brackets, but same thing. So we're going to simplify within them. 2 minus 6, negative 4. So now I have the last step is negative 4 times the 2, which gives me negative 8. Okay. Number 4. I'm going to stop asking you what all you see. Just tell me what it is we're going to do first. The exponent, right? So I've got 5 squared. So what is 5 squared? 25. What's the next step I'll do? The multiplication, the 25 times 3, which is 75. And then the last thing I will do is add the 2. So I have 77. All right. Number 5. What will we do first? The addition that's in the parentheses. It feels funny to say we're doing addition first, right? But it's because it's in the parentheses. 7 plus 2 is 9. So now this is the same as 9 squared divided by 3. What will we do next? The squaring. 81. I have 81 now divided by 3. It's 27. Very good. Okay, so now a couple things. Let me just pause right here. I know you guys have calculators, and I don't have any restrictions on what you can and can't use calculators for. I think that's kind of odd to have a restriction like that at this point because unlike it was when I was a kid, you always have a calculator with you because you guys have your phones with you all the time, right? So you do have a calculator, and it's perfectly reasonable. In fact, I would encourage you to check your work with it. But I don't want to see only these 2 pieces of information on your paper because I know your calculator can do it. I want to know if you know how to do it. Okay, so make sure you're showing me some steps in between, but still feel free, and I encourage you to check with your calculator, make sure you haven't made a mistake. All right, number 6, a lot more going on. All right, so what might we do first? The parentheses, very good. So the parentheses here is 6 minus 2, which is 4. So now I have 4 squared. Now what? Okay, so Malik's telling me that I'm going to do the 16 on bottom, right? 4 squared. What would be next? We would, and you'll notice, so we've been doing it, I haven't actually said it, but I want to say it now. You'll notice that I'm treating the numerator and the denominator completely separate, right? So while they aren't really written in there, there are these understood grouping symbols around the numerator and around the denominator. They're there, right? If you actually put them into a calculator with certain operating systems, they'll require you to put them because it will have to understand what you mean. So they're there, which means we're going to clean everything on top up and everything on bottom up before I ever do the division between top and bottom. Okay, cool. So, yep, we're going to do the multiplication on top next. So that's 12. 20 over 16. Yeah, we're going to reduce. We're not going to turn it into mixed numbers unless we're told to, and we're not. But we are going to reduce anytime it's possible to do so. So what do 20 and 16 both divide by? 4. If you looked at that and you said, I thought I was going to do 2, you could do 2. You'll just have to do 2 twice. You'll end up with a 5 on top and an 8 on... Wait, I wrote the 2 as I was talking. Sorry about that. 4. All right. And then a 2 on bottom. Okay. Sorry, I moved too quickly through that. You're right. Thank you. Awesome. Okay. If you changed it into 1 1/4, you'd be right. You wouldn't be counted wrong. You'd just have gone a step further than you really needed to go. Okay? Any questions on that one? All right. Number 7. What will we do first? The multiplication, right? So we're going to do this pieces over here first. All right, so we spent a good little bit working on fractions. What will we do in order to simplify or to multiply these fractions and simplify them? What would you like to do first, looking at them? Do you want to multiply or do you want to reduce first? Reduce? Okay, I've got both. So if you said you want to multiply, please do. If you said you want to reduce, please do. All right, I'm going to reduce. That's usually what I do first. But we'll check and make sure that everybody has the right answer, of course, at the end. If you reduce first, you'll see that the 6 and the 4 are both divisible by 2, right? So I have 3 on top and I have 2 on bottom. If you don't reduce, you'll reduce at the end. You're going to reduce somewhere. 1/5 is still 1/5, and then across the top I have a 3, and across the bottom I have a 10. Okay, if you did it the other way, you would have gotten 6/20. Yep, and then you would reduce it to 10/3. All right, so how are we going to combine these? What do we need? Hey, we need the same denominator, right? And so right now they don't match. One's 5 and one's 10. So what can I do to fix that? Yeah, so you can multiply the 1/5 by 2/2. That will give me a 10 in the denominator and they're a match. If you don't notice that, or if it's not quite so clean and obvious, you're welcome to multiply the two denominators together. That will work too. So you can multiply the first fraction by 10/10, the second fraction by 5/5. When you default like that, sometimes you get numbers that are bigger to work with, and you have more reducing to do at the end, but it'll still work. So on this one, I now have 2/10 plus 3/10, which is what? 5/10. Yeah, so I have to reduce that. They both divide by 5, which will give me what? 1/2. Always make sure to reduce when you get to the end of a problem. Any questions on that one? Okay. Last one, number 8. What would you do first? There's a couple things you could do, actually. You can do the division first. Okay, so if you do the division first, that's this piece. You'll still have a 6 minus. What is negative 44 divided by 11? Negative 4. Okay. Now what do you notice? You have minus a negative, which is the same thing as addition. So then 6 plus 4 would be 10. Let me show you another option on this one, just so that you can see one more way that you could think about this particular one. If you wish, because really the negative times the negative is a multiplication property, you could actually eliminate the negatives at the beginning as well. And it will work the same way. You'll still have a 6, but now you'll have a positive, and you'll have 44 divided by 11 for 4, and you'll still get the same 10. Okay, I want to show you the, I have to get it on my phone because I didn't put it in here. The message I got. So I have a previous student, he's actually in medical school. He took a calculus class from me, actually, when he was here. And he sent me a message and said, I know, he said, super random, and sorry to abuse your talents with this. I know it's probably insulting. I need your expert opinion on how to solve a dispute. And this was his question. Okay, that's what he sent me. And he wanted to know what the answer is. Okay, he's a smart kid, but he actually watched several YouTube videos and they conflicted in what their answer was, of all things. So we're going to answer him together. When you see this, what would you do first? Add the 2's, right? Because they're in parentheses. So we would have 8 divided by 2, and then now I have a 4 here. So then you're going to actually move from left to right to do the division, right? Okay, 8 divided by 2 would be 4, and then 4 times 4 is 16. So now I want you to think of when you saw PEMDAS before, and can you tell me what you suppose that the other thing is that people do when they do this problem?
4 times 2.
Yep, they do the denominator 4 times 2 part first because it's multiplication before they do the division. Because we've so ingrained in a whole bunch of people that the multiplication comes before division. And so there was apparently mass arguments in these videos that he was seeing on which one should be happening first. Yeah, so it is really important that we all do it the same way. It really is. Otherwise, we're going to have lots of problems in the field of mathematics and everything that comes after that, which includes physics and engineering and things like that, if we don't have a common way of doing that. All right, that's all I have for you today. You guys have lots of time to be able to complete this assignment before you leave. So go ahead and grab out homework number 7 and go ahead and get started, and I'm here to answer questions as you work.